In this video, I'm going to go over steps and procedures of creating a profile down the center line of a road. This pertains to an as-built of Roadway, which you see in front of you here. And I'm going to create the existing or the as-built centerline profile, and then over the top of that, I have these drain structures and lines, and I'm going to overlay on the same profile the drain line with pipe sizes and such. And all right, so to get started, there's basically minimum of two elements you need to this, and that to create this, and that's a tin and a centerline file. So we're going to start by just creating a tin. So I just going to go to the Surface tab. Now I'm using the ribbons, so if you're not using ribbons, the equivalent commands, well actually the redundant commands are in the Surface pull downs, centerline pull down menus, and etc. So I'm just going to use triangulate and contour. And the first thing I do is create a tin file, and I will call it as built road surface. And what I have here to create the surface from are just field points. Now this is just a straight download out of a data collector. I have not taken the time to pretty this up or anything. This is what comes out of the data collector using field to finish. If you're not familiar with that, there are separate videos on using field to finish. So the bluish looking lines are three-dimensional break lines. So Carlson defines a break line as a three-dimensional polyline, which is a polyline, whereas each vertex would have a different elevation. So that's all this is, points and 3D polylines. So I'm going to contour at a 1 to 5 interval. I'm not going to automatically label it. And for the selection, I'm just using the default Carlson selection options. So when I hit OK, I just window all of this in and hit enter. Now I get this error log, and if you notice I have some crossing break lines. These crossing break lines are ordered in largest elevation error to smallest, and you can see that it gets down pretty small. So the largest one is 3/10 of a foot. I can select one of those and hit zoom in, and what you'll see is crossing break lines where simply the shot taken in the field with the curb line crosses over the sidewalk line, so the elevations aren't exact because the curb line itself was not taken in the same location. Of course, the curb has a little bit of a reveal, so we're picking up some error. Like to edit these, you use straightforward CAD commands like trim, extend, move vertices, add vertices until you get any overlap or elevation errors out that you need to. I'm not going to go through and fix all of these. The center line of the roadway has no crossing break lines. They're all along the curb lines and sidewalks and such, which are not critical to this particular project. So once I do that, make those changes, I just re-execute the triangulate and contour. It pauses and says, do you want to overwrite the tin file? Yes, I do. Just reselect everything. And now I only have 14 errors, and I would continue on with these. Now when I get down to small errors like this, I most times would never bother correcting them. There's always going to be a few of those when you're working with raw field data. So once that's done, I have my surface model. I do like to take a quick view and look at that surface file, and you can see a little preview here, but when I open it up, I can see the surface itself, and I can see in here the turn off the roadway. You can see how it's formed, and the tin lines are going down the center line of the road, so it all looks good. Around the cul-de-sac, everything looks fine for this purpose. If I went too quick there, what I was looking at was 3D view, surface file viewer. All right, step 2 is to create a centerline file for the center of this roadway and extract the profile elevations out of that. So since I have the tin created, I can actually freeze these layers, which I'm going to do. So I'm going to freeze these point layers and contour layers just to clean up my drawing, and I'm actually going to freeze the break line layers. So now I just have 2D items making my life a little bit easier. So this polyline here represents the center line of this roadway. So that came from a design file. So that's the center line of the right of way that encompassed this roadway. So I'm using the design center line file. In this case, again, this is just a polyline. So my first thing I'm going to do is turn that into a centerline file. So go to my centerline ribbon, and under the centerline editor, I can select polyline to centerline file. So I pick that, and I have to name the file. I'm going to be consistent as built road, and save that. And then I select the polyline. It asks my starting station. The default is 0. I'm going to leave that default beginning at 0 plus 0. So I just hit enter, and it creates the file. That's all there is to creating that. If I double click on this file here, or I mean the centerline polyline, now you'll see that it's associated with a .cl file. And I do this so I can check that the centerline is going in the right direction. There was a prompt when I created it to reverse the direction if the polyline was going the wrong direction. I can also edit any of these elements and look at the radius and edit it if I need to. And I can redraw it. If I make any changes and hit save, it's going to update on the screen automatically. Now I'm going to take this center line and extract elevations from that surface model. So I go to the surface pull down, and from here it is under the profile section, this bottom section here, create profile from tin file. So I select that as-built road surface tin, open that up. It is a roadway type, link profile to triangulation. So that is if I update the surface model, the profile will update with it, which is a great option. I like to put it on prompt, so it prompts and tells me that it's going to do that. And then I hit OK. You can see that I have options for offsets if I wanted left and right. I don't need that. I hit OK. And now it's going to write a .pro file. Again, it's the same as built road. I'm just trying to be consistent with my naming, but this is the profile of the road. So I'm going to add CL for centerline, as built road centerline. Now, keeping in mind that we are going to add also a storm drain profile as well. I hit OK, save that, and then I have my choice to select a polyline or select the centerline file. Once I've already created the centerline file, it's a good idea to keep using the file, even though I should get the same results by selecting the polyline. I recommend going with the centerline file. So if I hit F for file, it prompts me to select it, and there's only one there right now, so I hit OK. And it successfully extracted the profile. Now to look at that profile, you can go back into Surface, hit Profile Editor, and now we can look at that. You can see it on the screen, and there's the profile that I got from the roadway. You see it's pretty smooth. So if there was any concerning points along here or variations in the road that didn't look like they were correct, you can edit it here or check your data and extract that if you needed to. But this is fine the way it is. So I hit exit. And now what I'm going to do is actually plot this. So I go to Surface, and I'm going to draw that profile. So when I hit Draw, the first thing that happens is this dialog box pops up, and I can set a reference center line, which I have. That's for stationing. And then I can hit Add File, and there's the profile. And when I hit OK, a dialog box pops up with all of the options that exist in the Draw Profile program. So for this same dialog box pops up if you're drawing roads or sewer lines, pipe crossings, all these different types of profiles you can draw. You get the same dialog box, so it looks a little more overwhelming than it really is. But we're going to start by just setting the scale, and I want to go at a 20:2 scale. And all the options I need for drawing the profile are going to be under road profile labels. I do want to draw a profile grid. So if I look at my setup here, here's my grid spacing, and you can go through and change these to however you want that to look. And it may take some trial and error before you get this just exactly the way you want it to look. And once you do, when you get these things set up, you always want to make sure you hit Save Settings and save those files, so then you can later load settings, which I already have some. Call it road profiles. And I don't have road intersections on this, but I have things set up the way I like. So if we go to road profile labels, you can see the types of labels I'm going to include. Now this is not going to have vertical curves in it. This is a generic profile with just a point every 10 feet or so along the profile. Now one of the things I got to check is when the draw horizontal axis elevation. So what I want out of this is I want to draw a grid for the profile, and then I want the elevations of the profile labeled here. So I hit Setup, and the existing grade that's correct. So it extracted that correctly itself, but it's always a good idea to check that. If I had two, existing and final, I would be printing both here. And then I set the precision, so I'm just going to have elevations drawn to the nearest tenth for this roadway. And I hit OK. And then you can control the layers here by the first profile name is going to be Profile Existing Centerline, so that's correct. And I just hit OK. And it scans the profile and gives some minimum and maximum elevations. Now I'm going to drop the bottom elevation because I know that I've got pipe structures here that are going to go deeper than the center line by quite a bit, so at least 5 feet. So I want to make sure I have enough room to draw those, so I'm just going to lower that. That says 180. I'm just going to go 150. Now I can always redraw that if it ends up being too big, but I'm going to go with that. And then on my cursor is the profile here. I took a second just there to change some layer colors so you could see them better. So here's my existing centerline profile, and down here are the elevations for every 50-foot station and the horizontal scale, and of course the grid. Okay, the next step is to get this information in for the drain, and this is a storm drain line, and then add that to the profile. So to do that, I first have to create a profile for this drain. Now you can see what I have is each structure and then labeled with a rim, an invert in and out elevation, and that should be consistent with each one of these. But I don't have a station on that. Now in this video I am using strictly the survey module. So if I had the hydrology module and the civil module, I have some automated ways of creating station offsets based on the center line as well as the elevations, rim elevations. There's a more automated procedure to do this, but if you only have the survey module, you can still get the same job done. It's just going to take a few more steps. So that's the way I'm showing you in this video. So let's start with getting stations on all these points. Again, I mentioned in the first part of this video series that I created this file using field to finish. Part of field to finish creates a point group for you automatically, and I created one called sewer and drain. So in here you can see my manholes and the catch basins all included in that group. So remember that as I go through this procedure. And then the next thing I'm going to do is go to the Centerline tab. Now we have some options off here to the side: Centerline repoint, offset point entry, and label station offset. So what I want to do is use that routine to label every one of these structures with a station and offset. So if I execute that, you would get a dialog box with a whole lot of options that I'm not going to get too carried away with. I am going to automatically add leaders to each station and offset, but simply what you do is you put the what's available field here on the left and use this is what I want to see. And that I'm just going to have station offset. So I'm trying to keep this really simple. Now for the center line, and again, instead of just using the poly line, I'm going to use the center line, and I can click on that and hit set, and there's my center line. So it's referenced to that. So once I have my option set here, I just hit OK. And you can see as I move around, you get a dialog box here that's showing me station and offset. Well, what I want to do, instead of picking on each one of these at a time, I'm going to click on Group and select the sewer and drain group and hit OK. And then hit Enter, and all my station and offset structures are labeled. So that will allow me to begin the work of entering this in the form of a profile. To do that, I'm going to go back to Surface Pull Down and back into that same profile editor. But this time I'm going to click on New, and As-Built Road, I'm going to call it Drain for Storm Drain Profile, and I hit Open. Now if you look here, I've got these 6 different types of profiles. A generic profile, just a station and elevation. That's what our center line is. A road profile that allows you to put in vertical curves and stuff like that. What we want is a sewer profile. So what I do is I enter in a station and an elevation. In this case, the elevation is the invert elevation. So you can see this first one here is 202.11 is the station. And the elevation is the invert. Now this has got an invert in coming from an offsite line that I don't have drawn on here, so I really want the invert out, which is 222.22. And then I go to the next station, and I can move this out of the way. The next one is 385.14. The in is 218.67, and then I have a step up. Well, in this case, it's not a step up, it's a down. All that means is, and it's a tenth, so I just put in a negative 0.1. It creates a step down. If you look at the way this is drawing to keep up here, you see it dropped that down. Then I go on to the next one. I'm putting in the trunk line. I'll come back and add catch basins and draw those separately. So it's just going to enter in the trunk line. The next one is 528.57. Elevation is 212.16. And it also has a step down of a negative 0.1. So I took a quick pause there and I entered all these in exactly the same way following that method: station, invert elevation, step up. Now I'm going to go back and add pipe sizes to this. You could have done this all at the same time, but what pipe sizes is 12 inch. The next run is 12, and this is 12, and then it changes to a 15, and a 15. Now, you'll see rim elevation. Now, when I can actually extract the rim elevation automatically from the when I draw the profile, it will draw it from the centerline elevation. However, we located each one of these rims in the field, so I'm going to add those here exactly on what the shot is, so there's no interpolation differences, that I'm getting these exactly to the elevation I shot in the field. So I'm at the end of the line now, so I'm kind of going backwards here. So this is 183.81. And I'm going to do the same thing. This is 193.17, and I just keep kind of going backwards here to 2.17, and I'm going to continue adding rim elevations. Now, of course, maybe it would have made more sense to do these one line at a time. Probably would have, but I didn't. I kind of bounced around through the spreadsheet, but you enter those in whichever way you feel is the easiest. Okay, so now I've got my data set completely set up. You can see the preview up on top that I've got each one of these structures in. This doesn't draw the thickness of the pipe here, but it gives you a preview of the invert elevation of the pipe. So once you get everything entered in, and again, in whatever format you want to do, if you're really good with Notepad, you can actually read this file and enter this information in Notepad, just following the format that you see. So once that's done, I hit save and exit. Okay, the final step is to put this all together. And that goes back to the surface pull down, and I'm going to draw a profile. So you can see I could just simply add the sewer line, the storm drain line, to this and redraw the whole thing, which is not a bad option. But I'm going to show you how to add a profile to an existing profile. Let's just say that this was all edited and looking exactly the way you wanted. You did not want to redraw the whole thing. So what I'll do is I'll remove that, and I'll add the drain, and I hit open and OK. So the reference centerline is the same. Now, when I'm looking at this, what I'm going to be looking at now for settings on how I want this to look is under the sewer pipe profile labels, and how I want these labels to be structured, and what order they're going to be in, etc. Again, once I get these settings the way I like them, I make sure that you save these. I have settings set up for drain lines. And you noticed that the draw grid now grayed out. So if you're going to draw on an existing profile, you turn off the grid so it doesn't draw the grid twice. And it also provides another prompt, which is exactly what I'm going to do here. And I hit OK. And that existing prompt or option that I'm talking about is right here, draw on existing grid. Now, if I had draw grid still toggled on, I wouldn't be seeing that. So I just hit draw on existing grid, and I can pick any part of this grid, and it draws the profile. Okay, let's take one final step, and that is to add stationing to our center line. That's back into the Centerline tab, and it's simply Station Centerline. Again, you're presented with a lot of options, how you want the labels set up, different marker options, PCs, spirals, like all the different elements of the center line can be labeled in a particular way. Again, I'm going to select the centerline file. Now I have settings saved for this as well, so I'm going to load those. I hit OK, select the centerline file, and there is the stationing. So at this point, you're ready to create plan and profile sheets, which I personally do in model space, and then create viewports for the plan over profile sheet layout.